So today we are going to discuss the wave optics, right? So in this chapter we will discuss the Young double slit experiment, interference, and the diffraction. The wave optics under this topic we will discuss the interference, right? Interference and diffraction. Also diffraction. Also we will discuss the polarization, right? Polarization. So there are the three topics we are going to discuss in this chapter. The diffraction here, in the diffraction, in the interference, YDSC we will discuss. From the diffraction, single slit experiment, single slit diffraction, and the polarization we will discuss. All right. So this is the very important chapter and very interesting chapter, which is based on the wave nature of the light, right? So the optics mean light, and the wave optics mean the light act as a wave for this case, right? For this chapter, YDSC, single slit, and polarization. So what is the light? So light is the energy, right? What is the light? Light is the energy which move from one point to another point, right, in the form of electromagnetic wave. Is it clear or not? So the light, when incident on the retina, it produces the sensation, right? It is the definition of the light. Light is the electromagnetic wave, right? Sometime it may act as a particle. For photoelectric effect, the light act as a particle, right? Light act as a particle, right? Particle. So this thing we will discuss in the modern physics, but here the light is the electromagnetic wave whose speed is what? C is equal to 3 into 10 to the power 8 meter per second in vacuum. Are you getting or not? In vacuum. So although light has the dual nature, right? Sometimes it acts as a wave, sometimes it acts as a particle. On this chapter we will consider the light is acting as a wave. Is it clear or not? Right? That is the thing. Okay. So what is the light? Okay. So the light is a wave. It is given by, first of all, the Huygens. So we will discuss the Huygens principle. Huygens. Huygens principle. Huygens principle. So according to the Huygens principle, listen one thing. Suppose this is the light. Are you getting or not? Light, the point source it is. So according to Huygens, every point on the present on the light act as a new source of light, right? From this, the wave fronts are emerging, right? And it produce, they move in the forward direction like this. Are you getting or not? So according to Huygens, every particle on the present on the wave front act as a new source of light. Act as a new source of light. And these new source of light are called secondary wavelet. Secondary wavelet. Right. And from secondary wavelet, the spherical wavefronts produce in the forward direction only. In the forward direction only. Is it clear or not? And the new position of the wavefront is obtained by joining the tangent, right? By drawing the tangent joining these wavefront. Are you getting or not? So light is moving forward direction in this way. Is it clear or not? Right. So this is the Huygens principle. I am not writing the definition. I think you understand this, right? So according to Huygens principle, when the wavefront, the light is propagate in the medium in the form of wavefront, and at every point present on the wavefront act as a new source of light, and this new source of light is called the secondary wavelet, right? And from this secondary wavelet, the spherical wavefront produce in the forward direction only, and the new position of the wavefront obtained by drawing the tangent joining them. So this is the new wavefront. This is the wavefront 1, this is the wavefront 2. Are you getting or not? So this is the point source. With the help of the point source, the spherical wavefronts are produced. Spherical wavefront are produced. Is it clear or not? Now, if you consider the line source, the line source. What is the line source? Suppose this is the tube light, or you can consider this the light source. So from this light source, the cylindrical wavefronts are produced like this. So the light is produced, right, radially outward from this cylindrical wavefront. So each, according to the Huygens principle, every point present on the wavefront act as a new source of light, and this new source of light is called the wavefront, right, from which the spherical wavefronts are produced in the forward direction only, and the new position of the the new shape of the wavefront is obtained by tangent joining these new wavefronts, right? So this is the new position of the wavefront. So this is the cylindrical wavefront, and the light wave in the form of the cylindrical wavefront propagate in the medium, right? So this is the point source, this is the line source. All right, copy this. Okay, so the plane wavefront, plane source of light. Plane source of light means if this is the source of light which is plane. Listen one thing. What is the plane wave source actually? If this is the point wave source, when the wavefront, the point source is very far away. So when this reaches to the long distance, this spherical wavefront converted into plane wavefront. Are you getting or not? So in plane wavefront, every point acts as a new source of light from which the spherical wavefronts are produced, and the new position of the wavefront, this is the 1 and 2, right, it propagate in this medium. Is it clear or not? So this is the plane wavefront. The point source act as a source of light, and long distance, right, for long distance. For example, the light coming from the sun to the earth is coming on the earth in the form of plane wavefront. Suppose this is the earth, right, this is the earth, and this is the sun, and from the sun the spherical wavefronts are produced, but when they reaches to the earth, so the light is coming on the earth, on our earth, in the form of plane wavefront. Is it clear or not? Sun. Copy this. So on the basis of the Huygens principle, we can explain the reflection and the refraction, right? For example, we can explain, the Huygens was the scientist, right, who explained the reflection and the refraction. Explanation of refraction, right, using the Huygens principle. What is the refraction? Suppose this is the light wave which is coming in the terms of wavefront, right? So when this light wave is incident like this, are you getting or not? This is the light wave when it is coming in this way. So according to the Huygens, every point acts as a new source of light. Suppose this is the rarer medium and this is the denser medium. Are you getting or not? In the rarer medium, the speed of the light is v1, which is equal to what? C upon n1. N1 is the refractive index of this rarer medium, right? In this medium, the speed of the light is C upon n2 and the refractive index is n2. Are you getting or not? So this is the plane wavefront. So when a new wavelight, when this wavefront incident over this, right, this is the incident angle. Is it clear or not? So from this point, the new source of light in the form of the secondary wavelet, when it reaches this point, are you getting or not? And this is the distance. Suppose this is the distance. In time t, the wavefront reaches from here to here, and this distance is v1 into t, right? S is equal to v1 into t. In time t, the wave front reaches at to this point, because what is the distance? Say v2t it is. Why it is v2t? So v2 is less than, v2 distance is less than the v1. Since the v2 speed is less than v1, so this distance is less. So the new position of the secondary, new position of the wave front is obtained by line joining them, right? So the new wave front become like this. Is it clear or not? So this is the v2t, this angle become r, right? This is the v1p, this angle is what? I. So this is 90 minus I, this is 90 minus I, this is I. If this is r, 90 minus r, this is r. Suppose this distance is a, this distance is b. Are you getting or not? So in this triangle, in triangle A, B, and I am assuming it is C and it is D. So in this triangle, in triangle BAC, BAC, what will you apply? Sin I. What is sin I? Is equal to perpendicular V1T upon hypotenuse. All right. While in triangle, this is the 90 degree ABD. In triangle ABD, what is the sin R? Sin R is nothing but perpendicular. This is the perpendicular distance upon hypotenuse. This is the equation number 1, equation number 2. Is it clear? So if 1 and 2 are divided, sin I upon sin R is equal to V1T upon AB, V2T upon AB. So everything will cancel out, V1 upon Vt. And what is the V1? The V1 is C1 upon N1, C2, C upon N2. So this is N2 upon N1, right? So sin I is equal to, upon sin R is equal to N2 upon N1. This is the Snell's law, right? So the Snell's law was proved by the Huygens principle, Huygens principle. So this is the explanation of the refraction with the help of the Huygens principle. Is it clear or not? So this is very important topic, right, which will be asked in the board examination also. They will ask that explain the refraction with the help of the Huygens principle. So you have to do this derivation. All right, copy this. Okay, so in the same way, the reflection can be explained. What is the reflection? Reflection. How to explain the reflection? Suppose this is the plane mirror. When the incident light in the form of plane wave front, incident over here, are you getting or not? So this is the angle I. According to Huygens principle, every point acts as a new source of light. So from here, the spherical wavefronts are, right, spherical wavefronts is emitted in the forward direction, and after some time it will produce the spherical wavefront also. So this, when this, if this is the V1 into T, so this radius is also V1 into T. Is it clear or not? So from here, when the new position of the wavefront will be like this. So if this angle is I and this is the V1T, this angle is R. Is it clear or not? So if I assume A, B, and this is the C, and this is C, and this is the D. Right. So triangle AB, what is triangle? If this is I, this is 90 minus I, this is I, if this is R, 90 minus R, this is R. Right. In triangle DAB, and in triangle BAC, the side is common, AB is common. Are you getting or not? Side is common. This angle and this angle, two angles are 90. Angle D is equal to angle C is equal to 90 degree. Clear hai kya baat? Right. And one another side, and side AD. This side AD is equal to V12 is equal to the side BC. Is it clear or not? So this is the side common, and one angle is common. So therefore the triangle DAB, right, and BAC are similar triangle. Therefore the angle I and angle R are same. Therefore the angle I is the incident angle, angle R is the reflecting angle. So both are same. So hence prove. So by Huygens principle, the reflection can also be proved, right? So now we will discuss the interference, right? So before doing the interference, before discussing the interference, we have to discuss first the very important thing. This is the coherent source, right? Coherent sources of light. Coherent sources of light. Can you explain something about the coherent sources of light? What are the coherent source of light, Sanjay? Okay, very good, very good. So if this is the source of light S1 and S2, right? If the light in the form of the wave travel, right? So if the phase difference between the two light sources remains constant with time, then these type of the sources are called, right, coherent source, right? And also their frequency must be the same, right? Source of same frequency, whose phase difference does not change with time are called coherent sources, right? Are called coherent sources. Copy this. So the very important point is that the two similar source of light cannot be coherent, right? It is not necessary coherent that the two bulb of the same power, if you take, everything is same, right? Color is same, light of the frequency is same, but there are two similar source of light cannot be coherent. Is it clear or not? So you have to make the coherent sources by the single sources only, because light is a property, right? If you consider the two bulb, suppose this is the bulb of the 100 watt, this is the another bulb of the 100 watt. It is similar in every respect, but still they are not coherent. Is it clear or not? They are not coherent. Do you understand? Since light is the property of an atom, property of an atom, right? When property of an atom, when the atom comes from higher energy level to the lower energy level, it emits the energy. So it is not necessary when an atom coming in the ground state for this bulb, the same time the atom is coming, it is not possible. So there will be the time difference. In the phase. So these two bulbs are not coherent source. Are you getting or not? The next topic is, okay, so the next topic is the principle of superposition. So this principle of superposition we always discuss in the wave, right? Whether it is electromagnetic wave, whether it is the wave in a string like that, or sound wave. So what is the principle of superposition? When two or more wave, right, propagate in the medium, all right, two or more wave propagate in the medium and reaches at some common point like this. So the displacement of the resultant wave is the vector sum of the individual displacement of the individual source. Is it clear or not? So this is called the principle of superposition. I am not writing the definition, just explaining it. When two or more wave, whether it is light wave or whether it is a sound wave, propagate in the medium, the resultant displacement of the particle, right, at a point in the space is the vector sum of the individual displacement of the all the sources. So this is called the principle of superposition. Is it clear? Copy this. Copy. So this is the principle of superposition. Now I will discuss the interference. Right. The next topic is interference. Now interference. This is the very interesting topic, and the wave optics start from here. Right. I discussed the small topics, right? The theoretical topics. Now the interference. What is the interference? You tell me the interference, Sanjay. If these are the two sources of the frequency is same and the coherent source are there, right? Coherent sources are there. When the wave propagate in the medium, are you getting or not? And when they propagate in the medium, so the intensity at a point in the medium is found to be maximum at some points and the minimum at some points. Are you getting or not? So the intensity is not uniform. Intensity is not uniform in the medium. Rather, somewhere it is maximum, somewhere it is minimum. So this type of phenomena is called the interference. I am writing, right, when two waves from monochromatic mean same frequency, and coherent source propagate in the medium, right, propagate in the medium in the same direction, then intensity found at different points is different in magnitude, right? Somewhere it is maximum, and somewhere it is minimum. Is it clear or not? This phenomena is called interference. Are you getting or not? This phenomena is called interference. Where the intensity is maximum, intensity. So that point or that interference is called, where the intensity is maximum. So this type of the interference is called constructive interference, right? Where the minimum intensity is found, so that type of interference is called destructive interference. So we have the two types of the interference, constructive and the destructive interference. Maximum intensity, constructive interference; minimum intensity, destructive interference. Copy this. So we have to find the expression for the constructive and destructive interference. Suppose this is the S1, right? Who's producing the light wave? S1 is equal to A1 sine omega t, and there is another wave. The amplitude or the intensity may be the different, but suppose the delta phi is the phase difference between them. What is its phase? Say omega t. What is its phase? Omega p is delta phi. What is the phase difference between them? Phase difference. What is the phase difference between them? Omega t plus delta phi minus omega t. So this is the delta phi is the phase difference. This phase difference between the two wave is constant. Suppose this is the pi by 3, pi by 2 like this. So if the phase difference between the two wave is constant, so these sources are called the coherent source. Also the frequency of the two sources is same. So therefore it is called the monochromatic source. But their intensity may be same or may be different, and the amplitude, therefore the amplitude may be the different, right? But you must know the intensity is proportional to the amplitude square. This is from the theory of the wave, right? From the class 11th, you must remember the amplitude, the intensity is proportional to the amplitude square. Is it clear or not? So now we can find the resultant wave amplitude or resultant wave intensity. Its source, this is the source S1 whose intensity is I1, this is the source S2 whose intensity is I2. If two waves are propagating in the median in the same direction, at this point we have to find the resultant intensity. Is it clear or not? So to find the resultant intensity, we will apply the principle of superposition. What is the principle of superposition? Y1 plus Y2. What is the Y1? Say A1 sine omega t plus A2 sine omega t plus delta phi. Right, this is the resultant wave. So resultant wave I1 sine omega t plus A2. Sine A plus B formula. Sine A cos B plus cos A sine B. Is it clear or not? Copy this. Okay, so now we can simplify this. A sine omega t plus A2 multiply by cos phi, cos delta phi sine omega t plus multiply by A2 sine delta phi into cos omega t, and you will take common A1 plus A2 cos delta phi. This is sine omega t plus A2 sine delta phi into cos omega t, right? This is the resultant wave. I will consider this is the AR cos alpha. I will consider this AR sine alpha. So the AR sine alpha is nothing but A2 sine delta phi, and AR cos alpha is nothing but A1 plus A2 cos delta phi. This is the equation number 1, equation number 2. Now we have to find the resultant amplitude. 1 square plus 2 square. If you square and add them, sine square alpha, AR square cos square alpha. This is A2 sine delta phi ka whole square plus A1 plus A2 cos delta phi ka whole square. Is it clear or not? So from here the AR square is common, cos square alpha is equal to A2 square sine square delta phi plus A1 square A2 square cos square delta phi plus 2A1 A2 cos delta phi. Is it clear or not? So it is equal to 1. Then listen, this is the A1 square, right? This is the A1 square plus A2 square sine square delta phi plus cos square delta phi plus 2A1 A2 cos delta phi. So it is equal to 1. A1 plus A2 square plus 2A1 A2 cos delta phi. Is it clear or not? So AR. So what is the resultant amplitude? A1 square plus A2 square plus 2A1 A2 cos delta phi it is. So this is the resultant amplitude of this resultant wave. So this is the wave y1, y2, and this is the resultant amplitude AR. This is the amplitude A1, this is the amplitude A2, right? So the resultant wave, when principle of superposition is applied, the resultant amplitude is given by this expression. Is it clear or not? Copy this. So these are the two waves, the amplitude A1, A2, when propagate in the medium, the resultant amplitude is given by this expression. You can check, right? And the resultant amplitude depends upon what? It depends upon the phase difference, right? It depends upon the individual amplitude A1, A2 and cos phi. Is it clear or not? Listen one more thing. If the intensity I1, if I assume, after this you can write, this intensity is proportional to I1 square, I2 is proportional to A2 square, and the resultant intensity is proportional to a resultant amplitude square. So from this, right, the AR square plus is equal to what? I am writing from here, AR square, A1 square, A2 square plus 2A1, A2 cos delta phi. Is it clear or not? So the resultant intensity we can find, this is the IR, I1, because they are proportional, I2 plus A1 mean root I1, right, like this, A2 mean root I1, root I2 cos delta phi. Is it clear or not? So this is the resultant intensity, I1 plus I2 plus 2I1 I2 cos delta phi. Is it clear or not? So this is the resultant intensity. Resultant intensity. It depends upon what? It depends upon the individual intensity and the phase difference, right? Now for constructive interference, constructive interference mean ference. It means the resultant intensity is maximum, right? So the resultant intensity is the maximum intensity. What should be the condition? It depends upon the cos phi. Cos delta phi must be equal to maximum value. So therefore the resultant intensity is I1 plus I2 plus 2 root I1 root I2 into 1. So it may be written as what? Root I1 plus root I2 whole square. Is it clear or not? So this is the maximum intensity. So the maximum intensity expression is root I1 plus root I2 ka whole square, right? So this is the condition for the constructive interference. The cos delta phi must be equal to what? 1. Is it clear or not? Copy this.